Welcome back. Today we have the fourth and last solution of this problem. The problem is called climb stairs. Problem number 70, climb stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can we climb to the top? We wanna know how many ways can we go to the top, basically. If we have the input 2, so the output could be 2 because we can go to the top in 2 ways, 1 plus 1 or 2 directly. If we have 3, we can go to the top 3 ways, 1 plus 1 plus 1 plus 1, or 1 plus 2 or 2 plus 1. And this is a way. However, to think about this problem, we could think about something called the Fibonacci numbers. The Fibonacci numbers often donated has often it's from a sequence where each number is the sum of the two preceding ones, usually starting with 0 and 1 in mathematic terms. So for example, we have n like if you can see here, n equals 3. Okay, the ways to get to the second one is 2, and the way to get to the first one is 1. So basically 3 equals the previous two numbers before it, if you can see it like that. So this is the Fibonacci number, what it's all about. It's a pretty straightforward, it's a pretty simple. So let's just try to create this one. If we wanna do this one, we wanna have our base case. So if n equals 1, we return 1. And we will start here. I will say let first equals 1, let second equals 2, and I will say I'll make for loop for let third, which will be the third. I'm picking first and second because we already know both of them, and it will be easier for us to manage it by defining first and second directly, and you will see why in the loop. So we'll say I third equals I equals 3, I equal 3, and I plus I less than or less than or equal n, and I plus plus. And I will say let third will equals, we said that all the time, it will equals first and second plus second, and we want to update the first and second. So first it will equals second, and second will equal third, and after that we return second. It's a pretty easy, pretty straightforward. Let's just describe the code here. So the climb stairs function takes an integer, as you can see, as input, and returns the total number of distinct ways to climb the staircase with n steps. It handles the base case itself. The base case, if n is equals to 1, there is only one way to climb one step. So we return 1 immediately. The code uses an iterative loop to calculate the number of ways for each step from 3 to n. It initializes first to 1 and second to 2, as there are 2 ways to climb 2 steps, 1 plus 1 or 2. We have inside the loop here, we calculate the number of ways for the current step, the step of I, and we the current step, which is the step of I, by adding first and second and storing the result in third. Okay. And after that, then we update first and second variables for the next iteration. First is set to the previous second, and second is set to the newly calculated third. And this process ensures that first and second represent the number of ways to climb the previous two steps for the next iteration. Number 6, the loop continues until it reaches step n after the loop completes. Second contains the total number of distinct ways to climb in steps. Finally, the function returns a second, which is the final results. So basically, this approach, it's a dynamic programming approach, or also using a Fibonacci number approach, and where we efficiently calculate the number of ways or to climb the entire staircase by iterative updating the number of ways for each step. So if you can find it for here, let's just take 4. So if we have, let's say that we have n equals 4. And I guess 4 it will equals, I don't know. Okay, so if we start, n was 4, I will equal 3. So start right now, and first will still 1, and 2 will still 2. So first we'll start I with 3. So third will equals first and second, which is 1 and 2, which will be 3. And first will be equals second, so this will be equals 2. And 3 will be equals third, which will be 3. And we continue looping, which will be I equals 4. And here we will have third will equals first and second, which will be 5. And first will equal second, which will be 3. And second will be equals third, which will be 5. And we return second, and after that the loop is ended, and we return second directly, which is 5. So it's a pretty easy, straightforward solution. It's even way more easier than the recursive solution. And yeah, that's it for this solution. Let's just submit it first, because sometimes it doesn't work. Yeah, it works. How satisfied are you with the new feature, dynamic layout? Yeah, it's good. It's good thing. Good work. No, I'm not continuing all of that. Just thank you. I'm only beating 32. This is fucking awful. Why is that happening? Let's see why. Let's see details. So it takes 54 milliseconds, and the other people that been better than me did 30 seconds. Okay, we did this solution. Actually, I'm pretty shocked, because I thought the Fibonacci number will beat like 90%. However, we making 54 milliseconds, so yeah, just a good one. Let's just try again. Maybe it's our solution is not that bad. Oh, we're beating 90%. Okay, I guess yeah, Leetcode has a problem or something. I don't know. So yeah, that's it for this video, and I hope you like my content. And if you like my content, make sure to subscribe and hit the notification bell so you never miss a video. And see you guys in future problems.